Hello everyone, this is Tamchalvi, Assistant Professor in the Department of Computer Science and Design at SNS College of Technology. In today's video, we will learn about linked list implementation from the topic data structure, one of the most important topic in data structure. Let's start. First of all, we must know what is meant by linked list. A linked list is a dynamic data structure where memory is allotted whenever required, so that the size of the linked list is dynamic. That means it can grow or shrink at runtime. The elements don't need to be stored continuously in memory. Instead, they are connected using pointers. This makes insertion and deletion much easier than arrays. Let's understand the concept using design thinking. The first phase is empathize. Students often struggle with understanding the pointers, insertion, deletion operation, and how to visualize the node connection. So our goal is how we can implement a linked list in Python in a simple and understandable way. The third phase is ideate. We will solve this using a node class, linked list, deletion, traversal, searching mechanisms. This structured approach make easier to learn. Structure of a node. Every linked list is made up of nodes and each node contains two parts, that is data and the next. First one is data that stores the value of data, and the next node that stores the address of the next node. We have three types of linked list. The first one is single linked list. In single linked list, each node contains data and the address of the next node. The last node points to null. The second type is double linked list. In double linked list, each node contains data and address of the previous node as well as the address of the next node. The address of the next node of the last node is null. The third type is circular linked list. A circular linked list is a linear data structure in which the last node points back to the first node instead of pointing to null, which makes a circular loop. We can implement this circular linked list in some applications like round-robin CPU scheduling, circular queue, music and video playlist, and traffic signal control system. Let's understand the Python representation for the structure of a node. The class node that creates a blueprint, and the init constructor that runs automatically whenever a node is created, and self.data that stores the value of the data, and the self.next that stores the reference to the next node. Creating a linked list. Head always stores the address of the first node, and if the head is none, the linked list is empty. Else, a node contains the data and the reference to the next node. The last node, that is 30 in the visualization, which points to null, indicating the end of the list. The linked list representation is 10, 20, 30, and finally none. Traversing a linked list. Traversal means visiting every node. We have to start from the head node, that is first node in the linked list, and visit the current node and move to the next node. And we have to continue the same process until we find none. Next one is insertion at beginning. Initially, we have 20 and 30 in the linked list, and we want to add a new node 10 before the current head, that is 20. So for that, we have to create a node that is 10 and store the data and make the new point to the current head, and we have to update the head to the new node. Next one, insertion at the end. Initially, we have the linked list with the elements 10, 20, and 30, and we are going to add the new node 40 after the last node, that is 30, after 30. So finally, we will get the output as 10, 20, 30, 40. For that, we must create a new node that is 40. If the list is empty, we have to make it as the head node. Otherwise, we have to move to the last node and connect the last node to the new node. Next one, insertion at specific position. Initially, the linked list contains the nodes like 10, 20, and 40. We are going to insert 30 at the position 3. Always remember, position count starts from 1. So we have to create a node, and if the position is 1, we have to insert at the beginning and move to the previous node. Then we have to update the links because we may need to traverse several nodes before inserting. Finally, after traverse to position -1, that is position 2, and after making a new node point to the next node and make the temp node point to the new node, we get the final output as 10, 20, 30, and 40. Next one, deletion operation. Deletion means we are going to delete the element. In two ways we can delete the element. The first one is delete the first node, and the second one is delete the last node. In the delete the first node, the head is updated to the next node, and the original first node, that is 10 values, removed from the list. So initially we have the elements like 10, 20, 30. After deleting, we have the elements like 20 and 30 in the list. In the second way, delete the last node. Uh, to delete the last node, we have to traverse until the second last node and update the next address as none. For example, initially the linked list has the elements like 10, 20, 30, and after deleting the last node, that is 30, we get the linked list as with the elements 10 and 20. The steps to delete the last node is, if the list is empty or has only one node, we have to delete the element. Else, we have to traverse until the second last node and set the next row of the second last node as none. Let's consider this Python code for searching in the linked list. In this Python code, we are creating a function named search with parameters head and key. Then we start from the head node and traverse each node one by one. If the key is found, that returns true. Else, if the end is reached, return false. So, the initial part of the linked list with the elements is 10, 20, 30, 40, and we are going to search the element 20. And the algorithm for searching 20 element in the linked list is, we have to start from the head node and compare the current node's data with the search elements, and if both are equal, display element is found and stop. Otherwise, move to the next node. This we have to repeat until the last node. Let's test our understanding. The first question is, which of the following is a linear data structure? The answer is linked list. Second question, each node in a single linked list contains, answer C, data and pointer to the next node. Question 3, which operations is most significant in linked list? Answer B, insertion at the beginning. Fourth question, which pointer indicates the end of the linked list? Answer C, null or none. Question number 5, which keyword is used to define a class in Python? Answer C, class. Thanks for watching this video till the end. See you in the next video. Thank you.